talk about difference of squares. This is possibly the easiest type of factoring that there can be. The most difficult thing sometimes is determining what's your perfect square and how to rewrite that. And I'm going to show you a little trick. With example 1, you should see that x is a perfect square because x is being squared, and 9 is a perfect square because the square root of 9 is 3. So I could rewrite this as x squared minus 3 squared, and sometimes it helps to rewrite it. Whenever you have the difference of squares, your factored answer is the first term minus the second term and your first term plus the second term. So this one is just easily x minus 3 and x plus 3. It could also be x plus 3 first and then x minus 3, because in multiplication it doesn't matter which order you multiply. Example 2, we have x to the 4th minus y squared. You need to be able to see that this can be rewritten as x squared squared minus y squared, because x squared squared is x to the 4th. So my factored answer is x squared plus y, x squared minus y. And again, it doesn't matter which one you put first, the plus or the minus. Example 3, you can rewrite this as 5x squared minus 4 squared, because 5 squared gets you the 25 and the x squared gets you the x squared. Remember, when you have only multiplication in parentheses, this is an exponential law or exponents law rule review. If you only have multiplication or division inside the parentheses, the rule says that you take the power and multiply it to the power of everything inside. So that gets me the 25x squared. But when I rewrite it, I can easily see that my answer is 5x plus 4 and 5x minus 4. Example 4 can be rewritten as 3x squared minus 8y squared squared. This y squared squared here gives me my y to the 4th. So I have 3x plus 8y, 3x minus 8y. Noticing in my examples, I'm putting the plus sometimes first and sometimes the minus first, but it doesn't matter. They're both correct. And this is 8y squared because my second term here was 8y squared. Example 5, we've got, doesn't look like we have a difference of squares, but if we keep in mind that every time we always want to pull out a common term. So what I would do first with number 5, I have a common term of 3. When I factor that out first, I get x squared minus 9 inside. And guess what I have here inside? The difference of squares. So what I have is 3 times x plus 3, x minus 3, because of the fact that 9 is really 3 squared, and that's how I did that. And finally, example 6, I have x squared squared minus 4 squared, which is going to be x squared minus 4, x squared plus 4, and I think I'm done, but examine what you have. Even though I've already factored once difference of squares, I have another one right here. What's inside parentheses right here is difference of squares. This right here is x plus 2, x minus 2. And what's left over here? X squared plus 4. So this is my answer.